on its house. And today we are going to do our first simulation, and it's gonna be a static structural, analysis. So I'm going to start by here. So I'm gonna grab this and slide it into here. So this is the static structural block. That's where we are going to work in order to do a static linear analysis. So first of all, I'm gonna enter in here, and open the engineering data so we can see how we can define the material. We already have structural steel material here, so we can either keep it or delete it and create another one, or just go in here in engineering data sources and then add a new one. So for example, now let's go back. Let's go back here. So if we look up here, let's check the values. Here we have in isotropic elasticity data. So we have the Young modulus, let's go in megapascal. So these are values that you can change, but you don't change them because they are correct. Yeah, everything is fine. Instead, we don't have the plastic properties, but it's fine. We don't need the plastic properties for now because it depends of the simulation we want to make. So this simulation that we are going to do is not going to we will not need to put to analyze plastic deformation, so we don't need to have this. But maybe in the second simulation that I'm going to do, it's going to be in the third video, maybe we'll go through this so you can see. So I'm keeping this because we also have the strength properties. I can see the tensile yield strength in here. Let's go to megapascal, and I can see as well the compressive yield strength. So the tensile is when we are doing a tensile when we are pulling, but compressive it's in compression when we act in compression. I mean the load. So yeah, we also have the ultimate. So the difference between the ultimate and the limits, I mean the yield, is that in the yield, when the stresses reach the yield, that means the material will go plastic. But when the stresses meet or exceeded the ultimate, or when it reaches the ultimate, that means the material will just fail. I mean, we have fracture. So that's how it is. So what I'm gonna do right now is to keep this, this property. It's fine. So let's close in here and let's go in geometry. So let's right click. I can either choose to go in design modeler or to go in new SpaceClaim geometry. So I'm just going new space. So here is the window of the geometry. So we can choose how we want to do it. We can go to File to import our geometry. I mean, we'll click File and then Open and take the geometry that we already have in our computer. So you can go in a CAD software and create your geometry and then transform it into step file or EGS, IGS, so whatever you want, but step is better. And then you come and import it and you will have it here. But we can also create our geometry from here. So let's click on rectangle and let's be this. And now let's go to dimension and give, let's say here, let's say 500 millimeter. 500 millimeter. And also you can go and change the unit if you want. But this is good for me to work in millimeter. So here I'm giving 1,000 millimeter. So we're fine right now. So what I can do is to go in circle and create a hole in the center, a hole. But this hole, I don't care about the radius. I don't give a, you know, you understood. So what I can do is to go in dimension. So let's be here from the center of the circle to this. It's gonna be 2 and 50. Let's do this. It's gonna be 250, and from this is 500, so 250 is okay, I think. Millimeter. So from this here is gonna be, but I don't understand why it's not the way it was supposed to be. So this should be 500. Sorry, 500. So the 250 is gonna be this. No, no, no. It's gonna be from this to this. This will be 500 or 250. Yeah, 250. So now the circle is in the center. So what I would do is to go to design and then pull, because here you don't have the tool to do the extrusion. So what you can do is to use the pull. You click on here and then you grab this till, let's say this is a good thickness. Let's go again. I think this is okay. So 110, we can put 110. This is our thickness. So now we're fine. If the geometry is already done, we can leave and then go to our workbench. Now geometry is done, properties are done. So now let's go to model. So here we have the window of the model. Let's do like that. Yeah, so now we're fine. You can use this tool, this one, to rotate it, or to use this to move it, or use your mouse the way you want. So what I can see in here is that the geometry is already assigned to the properties, so it's fine. It's already assigned, because sometimes when you create the properties, you may need to come right here and choose the material that you want. So here I can choose what I want in here. For example, the structural steel. This one, for example, I can choose this, as I can also choose to use the structural steel. So this is fine for me for now. For this simulation, we're fine for now. So let's go to mesh, right click, and then generate mesh. So when you generate the mesh, it's going to be an automatic mesh. So this is very pretty acceptable mesh. So if you go to quality, that's where you check whether you have a good mesh. This is good, but I'm just showing you in case you have a complicated geometry. So here it's about 1, so it's fine. We're fine. What you can do also is to go on mesh and change this and put, let's say, 25, and right click and update. So if you do that, you can see the elements that you are going to have now. These are small elements than what we had. So yeah, this is pretty good mesh as well. So we can put 0. That's the default value. You would just put 0, right click and update. Let's go back to what we had. That's an automatic mesh. Yeah, so this is, so now I have the mesh. What we can do is to go to static structure in here. So that's where we are going to set up the boundary conditions. So what I'm going to put at first is going to be a fixed support. So let's right click in here and say fixed support. Where is it? It's in here. But where to click? I don't know. Where is the origin? Is it this side or the other side? Let's right click on coordinate system and we can see it's this side. So I'm going to choose the face in here and let's right click literally, but I need to click in here geometry. And so you can see the fixed support in here. So what I'm gonna do right now is to apply the force. So I'm gonna apply a tensile force, so let's right click, or no, left click and equal this. Yeah, that means we apply the force in here. What I'm gonna do as well is to come up here instead of vector, I'm gonna put components so we can manage our load applying, our load we apply with the help of the of our coordinates. So here we have the y, no, because the force is a tensile load that I'm gonna apply. So a tensile load, I'm gonna use, I'm gonna follow the x axis. So let's say 10,000 Newton. So this is, a load that I'm applying. So now we're fine. I can right click and run the simulation by clicking on solve. So I'm going to wait, for seconds, and then I'm going to have the simulation. So now it's done. What I need to do right now is to come at solution and right click. What I want to watch is the stress analysis. I also want to see the strain, and I also want to see the deformation, total deformation. What I want to do as well is to add the strain total, equivalent total. So now I can just right click and click evaluate all results as the simulation is already run. So now I have the result. So I can click on stress. We can see it's not even 1 megapascal. So that means the structure will definitely hold, and it can last for almost forever. I don't know how many years, but we can see that, these a lot of generations are going to pass without it to be damaged. Why? Because the maximum stress is not even one. And we know the limit of this material is about 250 megapascal. So that means it's good. The material can withstand this load. And now you can see the structure looks like it's a little bit deformed, right here. Why? Because the scale is a little bit exaggerated. We can go to scale. When we put to scale, you can see everything is fine. So let's go here, graph, and then animate. You can see the way it is. But what we can do as well is to exaggerate the animation. Let's go to here and let's right click. So this is a tensile. So by exaggerating the animation, you can see that it's a tensile, but the structure is not being deformed this way in real life, but in real, it's this. So this is the way you do simulation on ANSYS. These are the steps, and this is a small model I wanted to introduce to the software. So I hope that helps. Let's see you in the next upcoming videos. Peace.